Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review what we went through in week 10. So week 10 was all about non-right angled triangles, finding unknown sides, unknown angles, or the area of non-right angled triangles. See, right angled triangles are really easy. But non-right angled triangles, we need a bit more sophisticated maths. So the way we label a non-right angled triangle is different than a right angled triangle. We don't call the sides here opposite, hypotenuse, and adjacent. What we do is we just label the sides with small letters A, B, and C. The big letters indicate angles, and it's important that you have side A opposite angle A, side B opposite angle B, and side C opposite angle C. So we learned two rules for finding unknown sides and unknown angles. These rules complement each other. You use them at different times. So the two rules, cosine rule and the sine rule. So make sure you understand this table that tells you the formula, but also when to use them. So if you want to find a side in a non-right angled triangle, you use the cosine rule. If you have two sides and the angle between, two sides and an angle, you use the sine rule if you have two angles and a side. If you want to find an unknown angle, you use the cosine rule if you know all three sides, and you use the sine rule if you have an angle and side pair. So that means like a side and its angle paired together, plus the opposite side of the angle you're trying to find. And the formula are in blue, so please pause and copy down if you need those formula. So it's really important that you remember these formulas. So we're going to use them to do questions like this. So here we're finding an unknown side. So we have its opposite angle and another side angle pair. We have two angles and a side, so we're going to use the sine rule to find x. We can't use the cosine rule to find x because in order to use the cosine rule, I'd need to know this side. So this is what the sine rule says. It says side over the sine of its angle, so x is opposite the 55-degree angle, so they're the pairing, equals side over sine of the opposite angle. So this is an equation to solve. Sine 55 is just a number, so the way we undo dividing by a number is we times each side by the number. So when I'm putting this in my calculator, I need to make sure I'm in degrees mode since the two angles were in degrees. Now, I don't expect anyone to be able to do this off the top of their head, but we can use some facts to help us see if our answer looks right. So in any triangle, the longest side is always opposite the largest angle, and the shortest side is always opposite the smallest angle. So this angle is larger than 55, so this side 12 needs to be longer than x. If I get a number more than 12, I know I've done something wrong. But if I put this in my calculator, I get about 9.98. So I know I've done something right because my answer is less than 12. All right, let's now look at this one here. So this time we're finding an angle x. We have all three sides. We use the cosine rule. We use this formula here. So when you're using the cosine rule to find an angle, it's always cos inverse. So it's the two sides touching that are added together. And the one you subtract is the side opposite the one you're trying to find. And on the bottom, it's 2 times the two adjacent sides. So don't be worried if this thing here is negative. It just means that the angle is going to be obtuse. So think about what I just said. The longest side is always opposite the largest angle. So x here is going to be the largest angle here. So it can't be something like 20 degrees. So if we put that on our calculator, making sure we're in degrees mode, to the nearest degree, it's 118 degrees, and we're done. I just need to make a special note about when you're finding an angle using the sine rule. So it turns out sine theta is equal to sine of 180 minus theta. That's actually a bit of bad news because it means when you're finding an angle using the sine rule, there's an ambiguous case. Sometimes there are two possible values for theta that you're trying to find. So what you need to do in order to account for that, when you get a solution, subtract it from 180 and see if that number is also a possible solution. So why is there an ambiguous case? Well, remember what I said about the largest side being opposite the smallest angle. See, in this one, we know because 15 is larger than 9, this angle must be smaller than 100. It turns out there's going to be no ambiguous case in this triangle. But in this triangle, angle, 17.8 is longer than 9. So 17.8 could be the longest side or the middle side. This angle here could be obtuse. It could also be acute. We just don't know. So let's go ahead and actually use the formula to find theta using the sine rule. So we have sine of theta over its corresponding side equals sine of angle over its corresponding side. So when we're finding an unknown angle using the sine rule, we put the angles on top. It's just easier. So rearranging this equation, what I'm going to do is multiply each side by 9. And then to get theta by itself, I need to take the sine inverse of both sides. Remember, you use sine inverse, cos inverse, or even tan inverse when you're finding an angle. So putting all of this on our calculator, we get the answer 56 degrees. So we need to check if 180 minus 56 is also a solution. But 180 minus 56 is 124 degrees. Now, theta can't be 124 degrees because the angles in a triangle add to 180, and 124 plus 100 is way more than 180. So in this case, there's no ambiguous case. But over here, it turns out there will be. We're going to do the same steps as we did here to find theta. So we have sine of angle over its side equals sine of angle over its side. Again, angles on top when you're finding an angle using the sine rule. So then we multiply each side by 17.8 and take the sine inverse. So putting that on our calculator, making sure we're in degrees mode, we get about 81 degrees. So theta here could be 81 degrees. Now, if I subtract 81 from 180, I get 99. See here, 99 is a possible solution. Absolutely, if one angle's 30, the other could be 99. We just don't know which it's going to be, whether 17.8 is the longest side or the middle side. So both of these are possible values for theta. That's what we mean by ambiguous case. All right, let's now move on to perimeter and area. So you already know how to find the perimeter of a triangle. You just add up all the sides. So if I want to find the perimeter of this triangle here, I need to find x. So I have two sides and the angle in between. So x can be found using the cosine rule. So using the cosine rule, we have c squared equals a squared plus b squared minus 2ab cos c. It's like c squared equals a squared plus b squared. It's like Pythagoras minus a little bit there. So remember, the number you get there is actually x squared. Whatever number you get here in your calculator, you need to square root to find x. So doing that, we get x is about 17.63. So the perimeter of this triangle is simply 14 plus 12 plus 17.63, so it's about 43.63 units. What about the area? Now, you're used to using half base times perpendicular height to find the area of a triangle. The problem is we don't always know the perpendicular height. Here, we don't know the perpendicular height. So we need another way to find the area of a triangle. Now, it turns out the area of any triangle is half AB sine C. So A and B are any two sides. C would be the angle between them. So if you have two sides and the angle between them, you can find the area very easily using this formula here. So the area of this triangle is just half, doesn't matter which you call A and which you call B, half AB times sine C. So again, you can put that on your calculator, making sure that you're in degrees mode, and you get about 83.68 units squared. So make sure you remember this formula for area. All right, let's now move on to using the area to find an angle or side. So for whatever reason, people found this a bit difficult last year. This is where we're given the area of a triangle, and we're given two of its sides, but we need to find the angle in between. So how would we do that? Well, we just learned that the area of any triangle is half AB sine C. Half times side times the sine of the angle between. So the area here of 67.66 equals half AB sine C. So, of course, a half times 12 times 12 is equal to 72. So all we do now is divide each side by 72, and that gives us sine theta. So when you've got sine theta equals something, what we do is take the sine inverse of both sides. So here, theta will just be the sine inverse of this, and that will give us an answer of roughly 70 degrees. All right, easy as. So let's now move on to our final topic of this video, which is bearing. So remember that the idea of bearings is this. If you told someone to start at a point and go northeast, they could go in this direction, this direction, this direction. All of them are in northeast. So to eliminate the ambiguity, we give each of these directions an angle, a number, a different number, so it's clear the direction in which you're going. So let's have a look at this question. Hugh and Xander both set out from the same point, same campsite. Hugh walks 5 kilometers on this bearing, Xander 8 kilometers on this bearing. We're going to find the distance between them. So let this be the campsite. If we're not given a diagram, we should always draw one. So because it's about bearings, I'm just going to draw an imaginary compass. So remember the angles that I'm talking about, these angles here, they're the angles made with the north axis going in a clockwise direction. Due north is 0 degrees, due east is 90 degrees, south 180 degrees, west 270, and it goes all the way back up to north, which is 0 or 360. So a bearing of 320 degrees would be over here. West is 270, north is 0 or 360. So a bearing of 320 degrees is in the northwest quadrant. So we'll just draw a line out here somewhere. So 360 is north, so this would be 40 degrees, and he has gone for 5 kilometers. So Xander, on the other hand, started at the same point, but he went on a bearing of 70 degrees. So remember, due east is 90 degrees, so 70 degrees will be somewhere northeast. So we'll just draw a line out here, and that angle there needs to be 70 degrees. Now, he went for 8 kilometers. So we have 2 sides here. To find the third side, to find the distance between them, which is this distance here, we need to make it into a triangle. So now we have 2 sides and the angle between. This angle here is 110 degrees. So we can use the cosine rule. So if I call this side x, the distance between them x, I have from the cosine rule, x squared or c squared equals a squared plus b squared minus 2ab cos c. Now, cos of the angle between them, the angle between them is 110. So if you put that on your calculator, remember that gives you x squared. You need to square root your answer, and you should get 10.79. And again, that makes sense. 110 is the largest angle in the triangle because you can't have another obtuse angle. So this side here must be the longest side of the triangle. It must be longer than 5, longer than 8, and we did get an answer longer than 8, so I know I've done something right. All right, sorry for the long video. Keep your head up. You're doing well. You're a superstar. This has been the luckiest maths teacher in the world. Have a great day.